we now discuss the solution of a problem from the section Binomial Theorem. And the question is related to the constant term in the expansion of the multinomial theorem. That means in the multinomial expansion, the question is related to the constant term. This is broadly categorized into binomial theorem. This question has appeared in the joint entrance examination main held on 29th June 2022 in the first shift. The given question is, if the constant term in the expansion of, in brackets, 3x cube minus 2x square plus 5 by x to the power of 5 whole to the power of 10 is 2 power k multiplied by L, where L is an odd integer, then the value of k is equal to, we are given 4 options. Option A 6, option B 7, option C 8, option D 9. We are given a multinomial expansion. It is consisting of the 3 terms, 3x cube minus 2x square plus 5 by x to the power of 5 whole to the power of 10. In this expansion, the constant term is of the form 2 power k into L, where L is an odd integer, required to find the value of k. We now discuss the solution of the problem in detail. We have the general term of the multinomial expansion consisting of the 3 terms we have taken here, x1 plus x2 plus x3 whole power n, where n is a positive integer, is given by n factorial by n1 factorial into n2 factorial into n3 factorial in the denominator, multiplied by x1 to the power of n1 into x to the power of x2 to the power of n2, x3 to the power of n3, where n1 plus n2 plus n3 is equal to n. Now, the general term in the multinomial expansion, 3x cube minus 2x square plus 5 by x to the power of 5 to the power of 10. So, n is 10 here, x1 is 3x cube, x2 is minus 2x square, and x3 is 5 by x to the power of 5. The general term is given by n factorial, that is 10 factorial by n1 factorial into n2 factorial into n3 factorial into the first term 3x cubed to the power of n1 multiplied by minus 2x squared to the power of n2 multiplied by 5 by x to the power of 5 to the power of n3, where n1 plus n2 plus n3 is equal to 10. Let us simplify this. This is equal to 10 factorial by n1 factorial, n2 factorial, n3 factorial in the denominator. 3 power n1 into minus 2 power n2, 5 power n3 into x to the power of 3 into n1 plus 2 into n2 minus 5 into n3. This is minus 5 because x to the power of 5 is sitting in the denominator. When it comes to the numerator, it will be x to the power of minus 5 to the power of n3, that is x to the, so you will get minus 5 n3, where n1 plus n2 plus n3 is 10. So what is our goal? Our goal is to get the constant term. Constant term means free from x, independent of x. So this is obtained by putting the exponential of x, that namely 3n1 plus 2n2 minus 5n3 to 0, subject to the condition n1 plus n2 plus n3 is 10. Yes. So we have two equations and 3 unknowns and a non-homogeneous system, and we get infinitely many solutions. But out of that, we have to get one solution. And for n1, n2, n3. For that, the constant term is of the form 2 power k into L, where L is an odd integer required to find the value of k. Agreed. So we take those two equations, 3n1 plus 2n2 minus 5n3 is equal to 0, equation 1. n1 plus n2 plus n3 is equal to 10, equation 2. So we have to solve. Now 2 implies n1 plus n2 plus n3 is equal to 10 will imply n1 plus n2 is equal to 10 minus n3. Take this value of n1 plus n2, substitute in the equation 1. So 3n1 plus 2n2 is written as n1 plus 2 times n1 plus n2. So n1 plus 2 times n1 plus n2 minus 5n3 is equal to 0. For n1 plus n2, we write 10 minus n3. This will imply n1 plus 2 times 10 minus n3 minus 5n3 is equal to 0. Simplify, we will get n1 plus 20 is equal to 7 into n3, and subject to the condition n1 plus n2 plus n3 is equal to 10. Now we make a trial. By a simple substitution. n1 is equal to 1 if I take it. n1 is only a trial. If it fails, I will go for n1 is equal to 2 and so on and so forth. n1 is equal to 1 if I put, it will be 1 plus 20, that is 21, is equal to 7 into n3. n3 is equal to 21 by 7, that is 3. So we got, if n1 is equal to 1, then n3 is 3. When n1 is equal to 1 and n3 is equal to 3, substituting in the equation 2, you will get n2 is equal to 6. Thus we got a solution of these two equations, and that is n1 is equal to 1, n2 is 6, n3 is 3. And let's go and substitute in the general term. In the general term, we substitute n1 is equal to 1, n2 is equal to 6, n3 is equal to 3. Then we get 10 factorial by 1 factorial into 6 factorial into 3 factorial multiplied by 3 power 1 minus 2 power 6 plus 5 power 3. These are the values we have put, and this is the constant term. And this is of the form 2 power k into L, where L is odd and required to find the value of k. So we do it in the next slide. So the constant term has come out as this one. 10 factorial by 1 factorial into 6 factorial into 3 factorial, 3 power 1 into minus 2 power 6 into 5 cube. Agreed. In 10 factorial, we cancel 6 factorial. The remaining ones will be 10 into 9 into 8 into 7 by 3 factorial into 3 power 1 into 2 power 6, 5 cube. Minus 1 to the power of 6 is plus 1. Now, this 3 factorial is 3 into 2. We cancel in the red one. So, if we cancel 3 into 2, we will be having here 2 power 5 into 5 cube. So, 10 into 9 into 8 into 7 into 2 power 5 into 5 cube. Write down the prime factorization. For 10, 5 into 2. For 9, 3 square. For 8, 2 cube. For 7, 7 only. 2 power 5 into 5 cube. Now 2 power 5 into 2 cube, that is 2 power 8 into 2, that is 2 power 9. And 5 cube into 5, 5 to the power of 4. So you will get and 3 square into 7. So this is of the form 2 power k into L, where L is 5 to the power of 4 into 3 square into 7. 5 is an odd number, and the product of odd numbers is again odd number. Therefore 5 power 4 is odd, 3 square is odd, 7 is odd, and the product of prime numbers is again prime. Therefore L is, I'm sorry, it's not prime. 5 to the 5 is an odd integer. 5 is an odd integer, and the product of odd integers is again an odd integer. So 5 power 4 is an odd integer, 3 square is an odd integer, 7 is an odd integer. The product is an odd integer. I'm sorry, it is an odd integer, it's not prime. Agreed. So the L is an odd integer, and 2 power k is 2 power 9. Therefore k is equal to 9. Let's look at our options. Our answer k is equal to 9 appears against option D. Therefore the answer to this question is option D. And that is the detailed discussion of the solution of the problem from the section Binomial Theorem, and the problem is related to the multinomial expansion. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.